Fine. Hello and welcome back, everybody. Today in geometry, we are going to look at a few more basic trig identities. So this from last time, we talked about the unit circle and how we're able to find the trig ratios for certain angles. So for example, what is a sine of 120 degrees, or what is the tangent of pi, and that kind of sort, right? So now we're going to create more identities, which again, identities are basically just theorems, kind of like, in the last semester and throughout this entire semester. And these identities, we're going to use them to build, I guess, more difficult equations, which we can then use in the future, okay? So now, from last time, as we said, we have the following identities. We have sine squared theta plus cosine squared theta is equal to 1. We also have tangent of theta is equal to sine divided by cosine. Then we have cosine of 90 minus theta is equal to sine of theta. And then finally, sine of 90 minus theta is equal to cosine of theta. So all of those we kind of we derived along the way. Now, we're just going to add on a few more with this one. So this time, according to the unit circle, which I've drawn over here underneath, remember the unit circle, what's supposed to happen is you're basically creating an angle, a central angle, where the initial side is at the 3 o'clock position on the x-axis over here. So here, let me just kind of draw that over there. So you can see my black ray right there. That's going to be the initial side. And normally what we'll do is we'll rotate counterclockwise, and as a result, we're going to go ahead and create an angle like so. Now, then somewhere on the unit circle right there, that is going to be the x-coordinate, which is going to be cosine of theta, and then the y-coordinate is going to be sine of theta. And the reason that is true is, well, this is a unit circle, so that means that the hypotenuse is always equal to 1. And in addition to that, if I draw the right triangle right here, you can see that the x-coordinate right here, the x increment and also the y increment would then be the same thing as the x increment over here and the y increment over here, according to the ratio of each of those sine, cosine, and tangent. Now, supposedly, what happens if I then rotate in the opposite direction? What happens if I rotate clockwise instead to create my angle? Well, in this scenario right here, you'll notice that if I rotate counterclockwise, I create theta. But let's say I'm going to go ahead and rotate counterclockwise the same amount then over here, like so. As a result, where this angle would then be negative theta. So for example, instead of increasing it by 30 degrees, I'm going to go backwards in the opposite direction to create negative 30 degrees. The coordinate that's down here, then you can see that there's going to be some sort of relationship between what we have and what we want. Now, thinking about like how the coordinate axes work, since we're in quadrant 1 on top, and then here on the bottom, we have quadrant 4, think about the x value and the y value. These two triangles that I have formed over here, this one over here, and also this one over here, they are definitely congruent to each other because of, some sort of SAS, ASA, or whatever this reason, okay? So now looking at the x values, well, you can see the horizontal increment for x is going to be the same thing. So then that means that cosine of negative theta, right, because that's what the x-coordinate is going to be the same thing as cosine of theta. So that is going to be my first identity in this case. So cosine of negative theta is going to be equal to cosine of theta. Okay, since the x increment is the same going forward as it is going backwards. Now, for the sine, we can do the same thing. I want to know what is the sine of negative theta equal to with respect to the original. Well, in quadrant 1, y is going to be positive, so that is going to be sine of theta. But unfortunately, when you go to, well, not unfortunately, but since you're in quadrant 4, you're going in the opposite direction, and you'll notice that you're now below the x-axis. So that means that it's going to be negative in this case. So one would say that the sine of negative theta would then be equal to the negative sine of theta. Okay, because the y values are going to be the negative of each other. Okay. And then finally, for the last one, is going to be tangent of negative theta. So we're trying to derive the identities for the negative angles in this case. Tangent of negative theta, one way you can think about it is, again, tangent by what we derive is the same thing as sine over cosine. So that means that this is going to be equal to sine of negative theta divided by cosine of negative theta. And those two we solved for recently. Top is going to be negative sine of theta divided by cosine of theta. So therefore, it is equal to the negative tangent of theta then. So right there, those are going to be my three identities in this case right here that we can that we derive. So we'll go ahead and just highlight these guys right here, and we're going to go see in how we can actually use them in our situations then. Okay. All right. So now that we have all of these right here, and we also have everything above in our artilleries, let's go ahead and try to solve for some of these problems. And I'm, having a little too much fun, kind of like marking these in like a little kid when I was younger. Okay, there you go. All right, so let's go ahead and take a look over here at some of these problems right here. The first one says, hey, evaluate what is the sine squared of 13 pi over 2 plus the cosine squared of 13 pi over 2. Now, note, these are values, and when I say these, I'm referring to 13 pi over 2. These are values that are on the unit circles. So what we can do is we can kind of like, rotate this direction until we get to that value. Here, if I rotate this way, that's going to be pi. And then if we rotate again all the way to the beginning, that's going to be 2 pi, which is the same thing as 360 degrees. And then afterwards, we go back, then it becomes 3 pi over here. Then when we go back to the very beginning, it becomes 4 pi. And then afterwards, we see 5 pi. And then after that, we're going to see 6 pi. And looks like that's going to be the same thing as 6.5. So that means that we're going to go over here. So this is going to be our position of 13 pi over 2. Okay, now we could look at it that way and then actually solve for it. According to what we just said, this coordinate, according to the unit circle, is supposed to be 0, 1. So therefore, our answer is going to be 1 squared plus 0 squared is equal to 1 then, because the y value is equal to 1 and the cosine value is equal to 0 at that coordinate. But the easiest way to think about this is, hey, we have sine squared of an angle plus cosine squared of an angle. And according to my theorem from the very beginning over there, the Pythagorean one, that is just equal to 1 so long as the angles are always equal to the same. So that's just a fast way of solving for it. In fact, one would even say something like the following. If I have maybe like say cosine squared of 47.5 degrees plus sine squared of 47.5 degrees, so long as the angles are the same thing, and I'm asking for cosine squared plus sine squared, you can always say it's equal to 1, regardless of if it's a value or a degree that we know on the unit circle or not. Okay, next one. Let's say this time that sine of theta is equal to negative 4/5. Then cosine squared is going to be equal to what? Well, for this one, we're referring to the identity also just as we just used. This one right here, sine squared of theta plus cosine squared of theta is equal to 1. Note that this is really just a direct substitution. Since we know what sine is equal to, then that means I can plug it into here. So sine is equal to negative 4/5. So therefore, sine squared is going to be negative 4/5 quantity squared. Plus cosine squared theta is equal to 1. Well, we just need to leave the, get the cosine squared all by itself, and then we're pretty much home free. So cosine squared theta is equal to 1 minus 4 squared negative, that's going to be 16, divided by 25 because it's 5 squared. So that looks like it's going to give you 9 over 25 then as a result. So that's going to be our answer over there. Okay. All right. So let's keep going with the same idea. This time we're going to go ahead and utilize the new identities that we just found. So this time we're asking, hey, if cosine of an angle is equal to 5 over 13, and that angle is located in quadrant 4, I want to solve for the following. I want to know what's cosine of theta, cosine of negative theta, and sine of negative theta, and tangent of negative theta. Well, first let's go ahead and draw this triangle so you can see what's given and what is it that you're trying to solve for. So here in quadrant 4, then that means that we're going to go ahead and draw a triangle. Now, the angle theta, since it's in quadrant 4, then that means we're going to start at the 3 o'clock position, and we're going to rotate all the way around like this. So that is going to be our triangle then, okay? The opposite is going to be, not opposite. Cosine is supposed to be adjacent over hypotenuse. So then that means that the 5 goes over here for the adjacent, and then the hypotenuse is going to be equal to 13. Well, if we know that, then that means that we can solve for the opposite part over here, which is going to be 12 because we can use the Pythagorean theorem. So in this case, the known are 13 and 5. So the way that we got the 12 is that 13 squared minus 5 squared is equal to 12 squared. Okay, so that's going to be the opposite side. And if you're wondering, well, why do we need the opposite side? Well, it's because if I know cosine of theta is equal to 5 over 13, now according to this triangle, we also know how to solve for all the other missing parts. That is to say, what is the sine of theta? And also, what is the tangent of theta? Well, sine of theta is equal to opposite over hypotenuse. Now, this is the part where you have to be very careful. The opposite is not actually 12, it's actually negative 12. And the reason for that is our angle is in quadrant 4. Y, the value of it, is going to be negative. So then that means that we have opposite, which is negative 12, divided by the hypotenuse, which is equal to 13. The hypotenuse is never negative because it is a distance, so it always stays positive. The only ones that can be positive or negative would be the legs. So it could be either x or it could be y in this case. So that's the tricky part. And that's the reason why we're given that theta is in quadrant 4. Then similarly, if I want to solve for tangent of theta, then that means it's going to be the opposite over the adjacent. So that is going to be equal to negative 12. That's the opposite of the angle. And then over the adjacent, which is going to be 5 over here. And you're thinking to yourself maybe at this point that, hey, it's kind of strange that my angle is actually outside the triangle. And it's technically okay because remember, that's the only way that we're able to use this unit circle to break out of anything that is over 90 degrees. Okay? But nonetheless, it's still in reference to that triangle over there. So now that we have sine of theta and we have tangent of theta, hey, we can solve for what we want. According to what we said earlier, right, for cosine, if I want cosine of negative theta, well, then that means that cosine of negative theta is supposedly equal to cosine of theta. And so then cosine of theta is equal to 5 over 13. So the first one is just 5 over 13, and then we're going to be done. Sine of negative theta, on the other hand, that is supposed to be equal to negative sine of theta. So negative and then sine of theta we have right here, we just solved for it. It's going to be negative 12 over 13. So the answer is going to be 12 over 13 then, okay? And finally, for tangent of negative theta, that is equal to negative tangent of theta. So that is equal to negative, in parentheses, negative 12 over 5, okay? All right, so there we go. That is going to be how we solve for these problems. So hopefully they, not too bad. The final one over here is the following over here. What I want to do is I want to solve for the other 5 trig functions of theta. Okay, so what that means is, remember, we're given the following over here. Cosine of theta is equal to 5 over 13, and theta is equal to, theta is somewhere in Q4. When I refer to the 5 other trig functions, that means all of the followings then. I want to know what is the sine of theta equal to. I want to know what tangent of theta is equal to. I also want to know what cosecant of theta is equal to, what cotangent of theta is equal to. And also, I want to know what secant of theta is equal to. And the only known right now is cosine of theta is equal to 5 over 13. Well, all of these we actually have because we solved for it earlier, right? Remember, we solved for sine of theta, and we also solved for tangent of theta. So now it's just a matter of filling everything in. So let's see here. Sine of theta, we said is supposed to be negative 12 over 13. Tangent of theta is equal to negative 12 over 5. And all the other ones on the right, they're just the reciprocals, okay? So cosine, let's see, secant is supposed to be the reciprocal of cosine. So that means it's equal to 13 over 5. This is by definition, okay? Cosecant, by definition, is supposed to be the reciprocal of sine of theta. So that is going to be equal to negative 13 over 12. And finally, cotangent is supposed to be the reciprocal of 1 over tangent. The reciprocal of tangent. So that is equal to negative 5 over 12 then. Okay, so those are the other 5 trig functions for theta in this case. All right, so I think that'll probably do it then for now. Thank you so much for watching. I will see you guys next time as I fill in these a little bit more. Okay, take care. Bye-bye.